Hey everybody, so this is my first video. I'm going to try to review the carbon cycle that we did in class today. So the first thing that you need to realize about the carbon cycle is that it consists of a couple of different things. So first one is probably the one that is most familiar to you, is photosynthesis. Alright, so photosynthesis is performed by, I'm going to put autotrophs or autotrophs, however you want to say it, and basically it's plants, phytoplankton, cyanobacteria. I'm running out of space. Alright, so here's the chemical equation for photosynthesis. So basically they take CO2, which is a gas, plus H2O, which is a liquid, and they turn it into glucose plus oxygen, which we like to breathe. Alright, and to balance this, all you have to do is do a 6 here, nothing there, and then a 6 there. So this is carbon dioxide, this is water, glucose, and oxygen gas. Alright, so this is taking CO2 out of the atmosphere and it is putting it into plants and trees and stuff like that. And this is how plants basically make their own food. So this is taking CO2 out of the atmosphere. Okay, and that's pretty much it that I want to say about photosynthesis. Alright, so the opposite of photosynthesis, let me switch colors, is going to be cellular respiration, or just respiration in general. Alright, so respiration is going to be performed by all organisms. And I say all organisms because plants and animals, and fungus, all do this to generate energy. Alright, so photosynthesis flipped is cellular respiration. Alright, I'm going to put cellular respiration here, so in case you forget, so cellular respiration. Alright, so here's the chemical formula for cellular respiration. It's just a flip, so you've got C6H12O6 plus O2 forms CO2 plus H2O. So 6, and then 6. Alright, so cellular respiration is going to be putting carbon dioxide back into the atmosphere. Alright, so this is going back into the atmosphere, and then photosynthesis takes it out of the atmosphere. Alright, so this puts CO2 into the atmosphere. Alright, so the CO2 that's being put off by respiration and combustion, which I'll talk about here in a second, is then used by plants and stuff and other autotrophs to do photosynthesis. Alright, so the third one that I want to talk about is where carbon dioxide basically dissolves into the ocean, and that's going to be called exchange. So I'm just going to put exchange here. Alright, process in which CO2 dissolves into the ocean. Alright, so this is the same process when we talked about how normal rainfall is slightly acidic. So CO2 that's in the gaseous phase is going to react with just normal water that's in the ocean. So that's going to be a liquid. Alright, and how this happens is the water just interacts with it. As the waves, encounter the CO2 that's in the air, some of it dissolves into the ocean. And when you do that, you form H2CO3, which is carbonic acid. Alright, carbonic acid is actually unstable at room temperature. So it almost immediately dissociates, and when I say dissociates, I mean break apart, into H plus HCO3. Alright, but then that is also unstable, and that breaks apart into H plus CO3 2 minus. So all of this is happening in the water, and again, it's a chemical equilibrium, so it goes back and forth, back and forth, back and forth. So what happens is the CO2 dissolves into the ocean, so CO2 gas plus H2O liquid, and it forms this thing called carbonic acid. Carbonic acid is unstable at room temperature, and therefore it breaks down into an H plus ion plus HCO3. Sorry, the lights just turned off. There we go. Alright, so then we're talking about this HCO3. It is also unstable. It breaks down into H plus and CO3, which is 2 minus. Alright, so this whole process dissolves tons of CO2 into the ocean. Only one problem with that is that this is actually actually causing pH of the ocean to decrease. So these H plus ions here are actually causing the pH of the ocean to go down, and this process is called ocean acidification. Alright, and ocean acidification is bad. So normally a small decrease in pH is normal for the ocean as CO2 dissolves into it. But with all the CO2 that humans are putting into the atmosphere, a ton of it is dissolving into the ocean, and it's this whole process called ocean acidification. So I would recommend memorizing this equation here, because last year it came up on the AP exam. It was one of the free response questions, and it was a part of the matching. Alright, so let's talk about another process. I'm going to put number 4 here. Number 4 is going to be the sedimentation and burial. So we've got sedimentation, and we've got burial. Alright, so the sedimentation is going to be when calcium 2 plus ions in the water react with CO3 2 minus. So the calcium here is going to react with this that was formed up here, and it forms CaCO3, which, if you remember, is called limestone. And the limestone is a solid, and it sinks to the bottom of the ocean. Alright, so let's talk about what this burial is. Alright, so I'm going to get another sheet of paper. And we're going to talk about what this burial is. Alright, so burial occurs when limestone or other dead organic matter go to the bottom of the ocean and eventually this is going to create fossil fuels. Okay? Eventually creates fossil fuels. So if you didn't realize this, fossil fuels are just basically dead or decaying organic matter that has been compacted and compressed for thousands or millions of years. And then we are going to do the next process. We can extract it. Alright, so extraction, and this pen doesn't work that great, but extraction is basically mining / drilling for fossil fuels. Alright, and that's releasing CO2 into the atmosphere through mining, releases CO2 from mining. Alright, which leads me to my last one, which is number 6, which is combustion. Alright, so combustion. Combustion is whenever a fossil fuel is burned, so coal, natural gas, oil, gasoline, like in your car, any form of crude oil, kerosene, so the list could go on and on. So whenever you burn a fossil fuel, or some people say whenever something is metabolized. So technically you could say that cellular respiration is a form of combustion, which it is. Alright, so we've got all of these different processes. Alright, so kind of to recap, we've got photosynthesis up here at the top. That is taking carbon dioxide out of the atmosphere, and then it is creating glucose and oxygen, which we like to breathe. Then we've got cellular respiration, which is going to be performed by all organisms. Remember, plants actually do cellular respiration if they want to, have some energy to do anything. Alright, and that's going to put carbon dioxide into the atmosphere as well. Alright, the next one is exchange. This is one of the biggest processes that puts carbon dioxide, it takes it out of the atmosphere and puts it somewhere, and most of the time it's the ocean, and it's actually causing a decrease in the pH of the ocean. It's called ocean acidification. Alright, sedimentation and burial is also taking carbon dioxide or carbonate that's in the water, and it's turning it into limestone. And then we've got the burial process, which burial is when the limestone or other organic matter goes to the bottom of the ocean. It creates these fossil fuels. We then extract them when we mine them or drill for them, and then we combust them, which then puts CO2 back into the atmosphere. Alright, so I'm going to make a list here. It says releases CO2 into atmosphere. Alright, the first one is going to be cellular respiration. Alright, number 2 is going to be extraction / drilling. And then we've got combustion. Alright, I'm going to put over here, takes in CO2 from atmosphere. And the 2 that we've got here is we've got photosynthesis, obviously, being performed by, plants and phytoplankton and stuff like that. And then finally, we've got the exchange process, which is CO2 into the ocean. I missed an O there. Alright, so hopefully this recap helped. I hope it wasn't too long and I didn't talk too much. Let me know if you have any questions.